Becoming a multi-planetary civilization is a pretty cool mission, but actually helping save the environment and the communities that we all love and protecting wild places for future generations, it is something that I think a lot of people can relate to and would like to help with.
Hey everyone, it's Schroepfer. I'm here with Brad Hartwig, who's the CEO and founder of Arbor Energy. Arbor is using wasted plant material to generate clean electricity and capture carbon. Welcome, Brad. Well, let's talk a little bit about this journey.
So I grew up definitely with a love for the outdoors and building tree houses. The first company I started was a treehouse construction business. And as I got older, I started to get more and more fascinated with flight. Actually, in high school, built a human-powered helicopter. So it was kind of a natural progression.
Okay, so it started with trees.
Yeah.
So after SpaceX, you went to Kitty Hawk, which is a eVTOL startup, and you were a test pilot amongst other things. So clearly your tolerance for risk is high because you're strapping yourself into a new vehicle. And then you went to start Arbor.
When I left SpaceX, my goal was to go work on basically building a competitive resume to become a NASA astronaut. I had a lot of intention around becoming a test pilot, joining the California Air National Guard, search and rescue. Through that work, I actually did a lot of response to wildfires. I was a search and rescue specialist. We did a lot of response, both in advance of wildfires, trying to get people to take evacuation warnings seriously, but also kind of clean up crew on the back end. Going into parts of Northern California that had just been scorched by these mega fires was eye-opening enough that I felt I'd been focused my whole career on getting off this planet and now was face to face with the climate crisis in a way that made me think I needed to really start focusing on how I could be a part of the solution for here on Earth.
I think a lot of people have this moment of clarity of like, oh crap, this is where I've got to spend my time. This is sort of what happened to me too. It's like, I'm going to rebuild my career to focus just on this. I'm sure a lot of people watching this are like, put me in, coach, but I don't know what to do. How did you get from where you were to, I'm going to go ahead and start Arbor Energy?
I just started reading and talking to people and learning as much as I could. This was in the wake of IPCC reports saying that global decarbonization was no longer enough. We also needed gigaton scale carbon removal. The technologies that need to be developed and deployed at large scale that don't exist today. And really just approached it from a clean sheet and just looked at fundamental thermodynamics and economics and what is the most cost-effective way of drawing down billions of tons of CO2 every year. And ultimately landed on one that had a surprising amount of overlap with technologies that I'd spent developing in the past. There was an opportunity here to create carbon removal that's a byproduct of power production, or vice versa, which is when you look at just how energy intensive carbon removal can be, that is a pretty significant opportunity. Carbon negative bioenergy was reported by the IPCC as one of the main ways that we could deploy negative emissions at scale. And yet there weren't really a lot of efforts being done to take modern engineering and modern manufacturing and applying that into carbon negative power station that could be modularized and deployed.
Tell us a little bit about what Arbor Energy is and what you're doing.
So Arbor Energy is taking waste plant material and converting it into carbon negative power and let plants do the hard work of scrubbing CO2 from the atmosphere, but then taking that carbon that the plant locked up and sequester it deep underground in geologic formation.
When we talk about unwanted biomass, you're thinking about thinning out the forests in California to prevent wildfire, and then we create a bunch of dead tree matter, and we have to do something with it. And that is an example of the source material you're talking about.
Yes, this is a huge problem, not just in California, but all over the globe. A lot of the forest land is just not treated, resulting in these mega fires. The work needs to be done to restore the forest back to its natural state. We just can't afford to do that work. There's no market for that waste material. That material is normally just piled and burned, or it's broadcast chipped, or in some cases it's landfilled. But in all those cases, it's going back into the atmosphere.
Okay, so you take this plant material and instead of just burning it, what do you do?
So what ends up happening is at high enough temperatures and pressures. This is all kind of where a lot of the rocket engine tech comes in. You can crack all of those longer hydrocarbon chains and it breaks it down into hydrogen gas, carbon monoxide, CO2, methane. It breaks all those bonds. We like to think of it as like a vegetarian rocket engine. A traditional rocket engine, like the Raptor rocket engine, runs on liquid oxygen and liquid methane.
Okay.
And those are both very high quality fuels. We're starting with a feedstock that is waste. You need to turn that into something that looks a little bit better for the engine to run. And so we end up with this two-stage combustion process.
Okay.
The first stage is called gasification. We feed biomass into a reactor that operates at really high pressures and temperatures, and we gasify the material. And then in the second stage, we finish combusting it. It's basically controlling the oxidation process so that you don't have any emissions leaving. You just have a stream of water and a pipe of CO2 that can be durably sequestered or utilized in making products.
So just sort of imagine this magic box. Input into the magic box is tree waste. Output of the box is carbon dioxide and water and actually heat that we turn into energy.
Yes.
And that would be clean energy at that point. And then that CO2 we can then sequester, we can reuse and inject into concrete. There's a number of ways to manage that because it's a highly pure stream of CO2.
Yes, exactly.
So why haven't we done this before?
Biomass, this was like the oldest form of energy. It's literally just burning biomass to, have a fire or cook your food. There are still bioenergy plants operating today. It does offer a base load power. Being able to operate 24/7 is what's kind of unique to biomass. When you look at using biomass for a carbon removal application, there's a tremendous amount of value in the carbon that the biomass is carrying. Monetizing the carbon, getting paid to remove CO2 from the atmosphere opens up relooking at bioenergy.
Got it. So the actual reaction we're talking about here is a well-understood reaction. There just wasn't a market motive to deploy it in the way that you're thinking. As a renewable energy, baseload 24/7 power is a really rare thing. The sun doesn't always shine, the wind doesn't always blow. The nice advantage of this from an energy perspective is it's 24/7 green power. And then from a carbon removal standpoint, it takes a tremendous amount of energy to be able to capture carbon. And in this case, you basically are capturing carbon but generating energy as opposed to consuming energy on the way.
Yeah, carbon negative energy or power positive carbon removal. It's a big deal because there's a huge demand for 24/7 renewables.
Yeah.
And there's a whole bunch of different options there, but varying levels of technology readiness or cost. We think carbon negative power is very unique in that it can be renewable power, but it can also be cost competitive.
Your co-founder, Andres, not only has experience with this at SpaceX, but also worked on gas turbines at GE in the past.
Yes.
How did you two connect?
So I actually originally interviewed his boss as a CTO, and I asked him, would he introduce me to any of the folks on his team that he felt were especially strong. Andres, he had both an incredible background on the rocket engine side as well as the power generation side.
Yeah.
And those have very distinct challenges. And you just have to be like very, very good at your craft in order to really get it right. We did the clean sheet design of the Raptor rocket engine's turbo pumps, and then also led the design of all the first stage turbine blades at GE for their H-class gas turbines, the largest machines on the planet for power generation.
What are the lessons you took from SpaceX?
Definitely a lot on the engineering side. First principles approach, questioning a lot of the requirements that were set and kind of where did those come from in the first place. There is a certain way of thinking that helps you become a good engineer. Are you able to think on your feet, and are you okay with pursuing, one option with 110% energy and then find out that it's wrong and then pivot and attack the next one with 120% energy? Or do you get defeated too easily? Those are things that kind of resilience that we look for. What we're doing has never been done before, and we are guaranteed to get it wrong before we get it right.
Yeah.
we were looking to get some test data for an oxy-combustion approach and found that we could take a wood oven and put some blowers and have some bottles of oxygen and pipe that in and basically run a loop to assess the control systems and see how would you actually operate this thing in the real world. And that, whole system costs $2,000 in total and can get to some very fundamental truths in a very quick way.
As an alternative to hiring a consulting company to do a 6-month study, built like messing around in our garage, 90% as good
Is
in
good enough.
A tenth of the time and cost, basically.
Yep. If you take that lens and apply it to everything that you do, it adds up very quickly.
Yeah.
It's not only the cost savings, speed is everything. So the faster that you can get to data that helps decide which path to go on is really important. I'm always looking for ways that we can increase our learning rates and get to solutions faster.
How have you found the fundraising environment?
Financing is a big thing that everyone is trying to figure out more broadly. What we have seen for what has been successful is demonstrate a working system at the smallest, cheapest, fastest scale that you can. And that will not be your product necessarily. We needed something that you can take people to and have them see and touch and show that end to end the system works. The goal is that you are scaling up. You don't want risk to be scaling as well.
Right.
And so how do you make sure that scale up that you did, is it a bunch of the same thing, just all stacked together? Or maybe it doesn't work like that for the entire system, but the most technically nuanced pieces all kind of stack like that.
Yeah.
Every technology is different, so it takes a lot of creativity to figure out what does modularity look like for your approach. And the more modular you can get things, the more compact, the more prefabricated, the more you can really reduce costs on the installation side of things.
So what's the cheapest, fastest prototype I can get to data? Build for modularity, particularly in the most technically risky parts. So when I go from 1 scale to 10x scale, I'm just making 10 of those rather than 1. It's not actually any different. So I'm taking no additional risk there. And sure, the blowers, the fans, the pipes coming in, they're bigger, but we don't have any bigger pipes.
People have a tendency to want to stay in their comfort zone. It's pushing yourself to really identify what are the critical failure modes in this and how do we go attack those with full force.
Running out the hard problems. Spend all your time on that thing that nobody knows how to do. Figure out all the ways to bulletproof that thing, get it so you can scale it up. The hardest part. Let's go spend all of our energy on that.
As an entrepreneur, what's so great about climate is that the problem is very real. And I know that what we're doing, the world really needs. And I can't imagine another team being able to do the type of work that we're doing. These are extremely bright people that could really be working wherever they want. They have developed some of the most complex machines on the planet. And yet we have all of them together in one room working on designing a product that could actually help make a real impact at a planetary scale.
That's a great way to end. Clear mission and team. Thank you so much, Brad. It was really fun to chat.
Thank you so much for having me.
Did we miss anything?
Sounds good.
Astronaut is still on the agenda for your future?
I would love to still go to space. Yeah.
That's awesome. That's awesome.